Cisco Certified Network Associate Day 9. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. So far we have learned a lot about different concepts. In our last video we learned about switching. So what we're going to do is today we're going to consider how switches or how network devices are going to interact, right? So we'll try to see how practically these devices are going to be stitched together. So without wasting much time, let's get straight into today's class. The first thing I want to talk about today is about topologies. So we have two different topologies. One is called the physical topology or the logical topology, right? So the difference between physical and logical is very simple, but I think that's one of the critical things that everybody need to know before they venture into the real networking world. Let's assume I want to travel. Okay, let me take a pen as usual. So pen, right? Okay, let's assume I want to travel from Dubai to New York, right? So I want to travel. So normally if you tell somebody, and if they were to draw on a world map, it will be just like Dubai to New York, just like a flight, right? Straight. But that's very logical way of saying, okay, it goes from here to there, you take a flight and go. But that's not how physically it is done. Physically you will have to drive to the airport, maybe first book a ticket, right? You book a ticket, you go to a travel agent, or you do an online ticket booking, you buy the ticket, you pay by credit card, or take a taxi, or maybe get somebody to drop you to the airport, or you can go to the airport, drop your car, check in, right? Show your ticket, check in, finish your security boardings, all those different things before you even get onto the plane. So once you finish that, you fly to the New York, and then again New York you have the reverse process where you finish your customs and finish your immigration, then you take your bags, you take a taxi, or you get a friend, or you get a friend to pick you up from the airport, and then you go to your destination, right? So this is how physically it is done. So logical and physical is like that. So when we look at devices, normally you will see people drawing network diagrams like this. So they will say, okay, PC is connected to a hub is connected to a switch is connected to another PC. So you have two PCs here, two PCs connected to a hub and switch is connected to each other, right? This is the logical topology. So if you go to Cisco Packet Tracer, if you have the liberty to use this software, Cisco Packet Tracer, you have a button here. So now we have chosen logical. So this is the logical topology. If I click on physical, right, I can click on physical, and let me go to that rack. So I can choose the rack. You say rack and just say jump to selection. We have gone into a rack, right? So this is how Cisco devices are connected. You will have a rack like this, right? Let me try to get a image from Google. Hold on a minute. Right, this is an image of a rack that I've got from internet, and this I don't take any rights for this image. This image is from the website. It is from c0op3r.com, images lab rack front, as you see on the screens here. So this is how a rack is. So a rack is going to be a physical rack like this, and then you have these Cisco devices connected and screwed on the sides, and so you will have like multiple routers next to each other, and you take wires and you connect and design the network like you want. So physically this is how the rack is. You'll have a rack, and as you add devices, these racks, so you can add another device here, you can add another device here, you can add another device here, right? And screw in the sides, so you can side, and you can design your diagram, right, the way you want by just plugging the cable. So in this case, you see this green cable. So this green cable is connected to PC00. You have the next green cable that's connected to PC1. You have the orange cable going to this orange switch. So hub and switch is connected using green cable. Then you have the next green cable goes to another device. So here I think they're only showing 3 devices. So you have a device here, it shows the device, and the green cable goes to the 4th device. So right, so this goes into multiple devices, right? So this is how physical topology is. So as you add more devices on your logical topology in Packet Tracer or in real life, it literally means a device goes onto a rack here, right? So this is something I want you all to understand, the difference between physical topology and a logical topology, because most of the time when you're doing troubleshooting, you might have devices connected like this, right? So you might have to, you may not get it in the logical form. You might be getting onto a new job, right? They may not have a logical topology like this. You will have to go to the physical topology, the server room, and look at these devices, trace them. You can use multiple protocols like CDP, for instance, right? So we'll try to talk about CDP maybe this video or the next video or one of the videos in future, right? You can use these protocols to identify what device is connected to what port, and you can physically look at it and draw your own logical topology, right? So that's one of the first things I want you to take before we start the class, right? So let's continue the class. So that is the difference between logical and physical topology. Okay, so let's do what we do, right? What we learned in our last class. Let me try to quickly go through these 10 commands or 10 basic configurations that we need to do with a new device. So let's assume this is a new switch or new topology that you're creating, a new device that's come, and you're just configuring these 4 computers, a hub and a switch, right? Right, so we have laid the switch according to what we want. So this is how we're gonna work today, and let's start with the switch. So we click on the switch, we go to command line. So we start with the switch. First let's start with configuring the host name. So we do host name switch 1, right? So we finished our first command, host name is done. What else do we have to do? If we go back to our thing, we finish host name, let's do log on banner. Alright, so this is better, so let's do it this way. So let's create the log on banner next. So it'll be banner MOTD, right? And we start with a character, so let's start ampersand. Let's put stars. Let's create our own message. Do not log in, this is a dangerous switch, you will be prosecuted, right? One of the things I got, from after our last video, one of the questions people asked me was, what if I want this character like ampersand, I started with ampersand, I want ampersand in my message. Well, it's very simple. Don't use ampersand, use something else, right? Use maybe bracket there. If you want to use a certain character in your message, then don't use that character as your starting character, because the minute I put ampersand here, let's assume I want ampersand here, right? So right now the message is here. So if I were to have a message which let's say I want ampersand this message, sorry, this what's wrong with me today? This message will not get saved, right? And I might think, okay, this whole thing is accepted, but well, actually not really. They have accepted only so much. So if I go to do show run, right, you can see that my logon banner ended here, because after this the next thing I added here was the ampersand sign. So there's nothing after ampersand, whatever I typed did not come in my logon banner, right? So that's something we need to keep in mind, that if I want, right, ampersand in my message, I would maybe start with something else, maybe in an close bracket, right? Then I would put that message here, right? Right, I can say Tony and Guy networks do not log in if you are not authorized, right? And I can end with the exact same bracket. So I would do the same bracket and my message gets saved, right? So this is something you need to be careful. If you want a certain character in your message, then don't start with that character, right? So that's with the logon banner. Let's set the console password. So Console, as we know, is line, so we say line console 0 because there's only one console port in every switch, so line console 0, right? I need to set a password, right? So I'd say password Cisco, right? Or let me say password console, just to identify different passwords, and I need to say login, right? So what does login mean, right? Some people say, like some people think this, that when I say no login, what does that mean, right? Well, if you're thinking no login means that it does not let people log in through console port, you're absolutely wrong. No login means there is no checking for login, right? So it's like this. When I say login, it is like putting a security guard at the door. Everybody who comes in, the security guard is going to ask for identity. They're going to ask what's your username, what's your password. If it is right, they will let you go through. If you say no login, it is as if taking the security guard away, right? So it's like leaving your door open. So don't get confused. No login means everybody is allowed. Every traffic coming through the console port would be let through without asking for a password, and that's the default behavior of every Cisco device, that the console port is open. Anybody connecting through the console port can come in. So one of the first things you need to do after getting your switch is configuring the console port to prevent unauthorized access by putting a password and putting the word login. So let's do that. Login, and we've set the password. Next, we need to set the telnet password. So telnet is again a virtual line, so we say line VTY, right? VTY is virtual line, right? And then we can put numbers from 0 to 15, so we say 0, right? I can put from 0 to 4 or 0 to 15. Let me do 0 to 4 now. I'll show you something. Right, again the same thing. I say password. The concept is the same. If I put password, that is the password that it is going to ask for. So we say login password, we say password, and I say telnet, and I say login, right? When I say login, it means that the user, anybody coming in through the telnet lines, should be asked for a password. So let's do this. Do show run. Let's see what happened in our running configuration. We see that there are 16 lines. So line VTY 0 to 4, right? And line VTY 5 to 15. The first thing anybody should ask me is, why do we have half 0 to 4 separately, and then you have 5 to 15 separately? Even if I were to, let's say, even if I were to go, and if you're thinking that it is if you're thinking it is broken down that way because I chose line VTY 0 to 4, then it's not the case. Let me try this. 0 to 15, that's the maximum I can put, just to show you. If I say question mark, it says 1 to 15, so I will say 15. That means line 0, line 1, line 2, line 3, line 4, line 16 up to line 15. That means 16 lines are available for users to come in, which means that on that switch 16 people can simultaneously log in. So whatever configuration that I'm going to make now, it will apply to all the 16 lines. So if I put a password line, if I put a password here, that's the password for all 16 people, right? Right. So if I say password telnet, and I say login, right? By default login is there. So now if I say show run, and if I go down, it says line VTY 0 to 4 password telnet, line VTY 5 to 15 password telnet, and login. What does this mean? One, like I said, 16 people can log in with this password telnet and with login. And the reason why we have 0 to 4 and 5 to 15 different is because every device Cisco made from a very, very long time had only 5 VTY line. Only the newer devices have 16 lines. So Cisco thought, instead of saying 0 to 15, so line VTY 0 to 15, if they had to make it one command, backward compatibility was a problem, because as you become more and more familiar with the Cisco technologies, you will reach a place where you will be actually copying running configurations and pasting it onto devices, and those devices will get configured because Cisco CLI is copy and paste enabled, right? So if you had a command like line VTY 0 to 15 applied to a switch which only had 5 lines, that command will not be accepted. To prevent that, Cisco said even if you have 15 line switches, they thought they'll break it down into 2 different commands. So this is one set of command 0 to 4 which is applicable to all the devices Cisco has ever made, and this is applicable only to the new devices. So if somebody chose to copy the running config from a newer switch and apply it to an old switch which only had this, well, those 5 lines will get configured because this is a valid command on that. This part will not get configured because that device will not understand what is line VTY 5, right? So at least you have your 4 lines, which is the only 4 lines that it has. So those 4 lines will get configured, right? So this is why we have broken down into this way. I mean, this is why Cisco has broken down into 0 to 4 and 5 to 15. Now, now let's try. Let's say we don't want 0 to 15, all the lines open, right? So I say no. Sorry, right? So if I want to disable VTY, I can't say no login. You might think I can say no login. Well, if I say no login, what will technically happen is line VTY or the VTY telnet line is open for everybody to come in, right? But that's not what we want. We want to prevent people, right? So let me do this. We have done this. Let's just skip that for a minute. I will put the management IP so that we can telnet into the switch and show you what exactly I mean. So I'll go interface VLAN 1 IP address 10.1.1.10 255.255.255.0 no shut, right? I have made this. I'm gonna go back into this device, right? I'm gonna, let's say this is this device, let me configure an IP address on this. So I'll go here, I will say 10.1.1.1 255.255.255.0. okay, I'm gonna set this because this is all one single network, so I don't need a default gateway, right? Right, so first let me ping 10.1.1.10. Will it ping? Of course it will, right? Why is that? Yes. Okay, that's because the first one is up, so it's sending an up, it's learning the MAC address and all those things it had to do in the first ping, right? So it can ping. So let's try to telnet 10.1.1.10. boom, I'm inside. It did not ask me for a password. Why? Because we just opened that line. If you see here, I opened that line. I said no login for all the 16 lines. So line VTY 0 to 15, that means all the 16 virtual lines or telnet lines, and I said no login, which means it's open for everybody. Anybody who's got access to this network can tell into that IP address and they will let you go in. I can make all changes on the switch, so I can say enable. So yeah, I can't. This is one of the fail proof mechanism that Cisco has set, so that even if somebody gets in, unless there is an enable password configured, it will not let you through. So let's create an enable password. Enable password Cisco. Let's say enable, just to identify the password, right? Enable password enable. I say enable and password is enable, and it lets me in. So now I can make all changes on the Cisco device, right? So yes, Cisco has a fail-proof protection by having an enable password that is mandatory if you were coming from a telnet device. That enable password, even though we did not have enable password, it did not have a problem with us using, because like I said, this device, when you click and go to CLI on packet tracer, it's as if you're connected from console port. So this is, for all practical purpose, this is a console port connection. So if you're coming from a console port, even if you don't have enable password, it will not have a problem. It will let you access, it will let you do all the configuration, right? But if you're coming from a virtual line, telnet line, it will not let you access without enable password. So we have done the enable password, so that's all right now. So we don't want this thing to log in without a password, so we are going to wait. We are going to create a password. So line VTY 0 let's say we want only one line, so we say 0 to 0, right? Okay, so we say line VTY 0. Line VTY 0, what does that mean? It means that only line VTY 0, that's first line, is enabled, right? And I'm gonna put a password login, right? Password telnet, but I'm going to disable all the other lines. So how do I disable? Line VTY 0 to 1 to 15. That means I'm not configuring line VTY 0, which I want to access. I'll say no password, right? And I will say login. Now what does this mean? Login is disabled on line 2 until password is set. That means what I've technically done is I have put, so if I go here, show run, and if I see, this is what has happened. Line VTY 0, that means first line, I put a password and it is logging, no problem, so that will work. But line VTY 1 to 4, login is enabled, that means there is a security card, but there's no password set. That means security card is not going to accept any password because the password is not set, right? So that's what it says in this message. It says login is disabled on line 2 until password is set. So now if I go from here, let's say I say telnet 10.1.1.10, right? It's asking for a password, and this is telnet, so I do telnet as a password. And let's say I configure this device also now. So let me configure this device 10.1.1.2 255.255.255.0. I don't need gateway because it's the same network. I'm not using router, right? So I'll try to ping 10.1.1.10. It'll take one ping for ARP and then it should reply, right? So perfect. So it's replying now. Now let's do telnet 10.1.1.10, right? It's trying to open, but it's not letting in through because there's already one connection. So if you see here, PC0 is already connected to telnet. So unless this device is disconnected, I will not get access here. So let's try to disconnect. I say exit, so I have disconnected. Now will it let me in? Of course it is letting me in, asking for a password. I'll put telnet as a password, telnet as a password, and it has let me in, right? Enable is the password here. So if I want multiple devices, I can configure accordingly, right? So I've just configured to have one telnet device accessed. Right, so let's look into the next thing. So we have done telnet password, enable password, so we have done with that. Next we'll look at management IPs. Of course we have already configured management IP. Next is in case, right? In case this switch is going to be managed from another network, this switch needs to understand how to go out of the network, right? So in your computer, we go into your computer. So if this is the computer or any device, we need to configure a default gateway. So we configure default gateway. Let's assume our router or the gateway IP address is 10.1.1.100, right? So we'll come and configure this. The minute this device tries to communicate with another network not part of 10.1.1.2/24, because this is 255.255.255, so any device, any communication that this device is trying with anything other than these first 3 octets different from 10.1.1, this device will send that traffic to 10.1.1.100, which is its gateway, right? It's, if you go back to our IP address videos, we know what default gateway is, and the hotel example is it's very easy to understand, right? So if you want to exit from your hotel and go to another hotel, you have to go through the gateway, right? So similarly, this is the gateway. Now this is how we configure on a PC or a computer or whatever device that you use, end device. But on a switch, right, especially since switch is a layer 2 device, we need to configure IP address, which is layer 3. So how do you configure layer 3? We create a management IP by going to interface VLAN 1, right? And I understand that VLAN is a concept that we have not touched, and it's a little big topic. We will keep it for the next video or the video after that. But just know that when you start a switch, when you buy a switch, a brand new switch, all the ports in your switch are configured or are all part of VLAN 1. So to manage the entire switch, we give an IP address to an interface called interface VLAN 1, right? We already gave an IP address which is 10.1.1.10, right, through which we try to access the device. But if we want to configure an IP default gateway, so we need to say IP default gateway 10.1.1.100, right? This means if there is a requirement for this device to communicate with another network, right? How did we know the network? So if you go back to our running config, we see that the IP address given to interface VLAN 1 is 10.1.1.10/24. That means the switch knows that anything other than, if the first 3 octet is anything other than 10.1.1, it needs to send the traffic to the default gateway which we set by this command, right? So this is how we set the default gateway for the switch. Now again, if you want to shut down any port, how do we do that? We use the command, interface f0/0. Sorry, I'm very sorry. Okay, another thing, this is good that I made this mistake. If you see routers, we haven't reached routers, so that's all right, I think, but still I'm going to tell you this. Routers will have numbers starting from f0/0 or g0/0, but switches will always start with f0/1, right, or g0/1, depending on whether it is gigabit Ethernet or fast Ethernet. So in this case it is fast Ethernet, so it's f0/1. There's nothing called f0/0, and that's because routers were made by Cisco. Cisco invented the routers, so routers number scheme for Cisco always started with 0/0 and they continued. Switch it's a catalyst switch, and it is a switch bought from a company. Cisco acquired the switching technology from another company. I think the company was called Kalpana or something. It was an American company. Some American Indians were there, that's why they have the name called Kalpana, which is a very Hindi name. So this catalyst switch was acquired from this company, right? And that's why they already had a naming convention for their interfaces starting with f0/1, so they continued with that 0/1. So switches will always start with 0/1, or g0/1 or f0/1, right? So just clearing that. So if I want to shut down this port, I just say shut down, right? That's it. That port is physically down now, right? So if I want to open the port, I just say no shut down, right? So the word no, right, you can see that change state to up. When I said shut down, it said change state to administratively down. So let's do this. Let me do shutdown again and do show IP interface brief. Okay, these are the commands that I think you will have to note down somewhere. These are all the troubleshooting commands. So this is one of my favorite commands, show IP interface brief, because it gives you a quick snapshot of all the interfaces in the switch. So if I look at this switch, I can see that port 1 fast Ethernet 0/0 or 0/1 is administratively down. The minute I see administratively down, this means that switch has been shut down with this command called shutdown. But if you compare that to this down, right, this says status is down. So here it says administratively down is status, and protocol it says is down, right? So protocol will be up when there is any traffic, right, some broadcast traffic or some traffic, right? Then you'll see some current in that port, then it says protocol up. But when you just see status as down, that means that port is open administratively, there's no shutdown here, but there's nothing connected, right? These ports, if you remember from our topology, let me show you here. So switch 1 is connected, 2 is connected, 3 is connected. So 1, 2, 3 is down, but I have made this port down. That's why this has gone to red, because I have administratively put it down. Let me try to enable that. So I say no shut, and it says changed state to up, and within few seconds this will go up. Right now it is negotiating. Within few seconds that should go up. Okay, so that's how you negate commands. So shutdown and no shutdown, that's how you. Finally, we'll get into saving configuration. So how do you do that? We say write builds configuration and it saves. Another way of doing that is copy running to startup, running to startup. So it says destination file name is startup. Whenever you see something in these square brackets, you can just hit enter if that's the right command that you want. So it's telling destination file name should be startup configuration. You say yes, and it builds configuration, and this whole thing is saved, right? Now let's go back to our diagram. We have one big problem in this, right? We have one big problem, and for people who are slightly aware of how hubs and switches work, which all of you should be by now because we have already discussed switches and hubs, you would understand that the difference between switch and hub is this, that if this computer is communicating with this switch, or let's say this computer is communicating with this device, the traffic is only flowing between these two devices. But on the other hand, if this device is communicating to this device, right, this hub will send a copy down on this port. So let's say this communication is happening like that, right? They are talking to each other, so I'm going to put an arrow on either side. The hub, instead of just sending that traffic on either on these ports only, it's going to send a copy to the switch, right? That's how hubs work. Now that's the problem is also, so let's assume you're the administrator, right? And let me see if I can erase this, right? So I'm erasing this, okay, right? So let's assume you're the administrator sitting on PC1 and you're trying to telnet to this device, right? You're telnetting to the switch and you're going to make changes. Everything that you're sending from here to the switch will be read. Let's say there's a hacker sitting here in PC0. He can read everything because he gets a copy of whatever communication that this PC is doing with the switch. So he sends a telnet request. The switch will reply with that prompt of username and the password prompt, right? So there are many packet analysis softwares available, like Wireshark, for instance. One of the most beautiful softwares for packet analysis is Wireshark. It's a free software. We will be using Wireshark as we go along in this series, but you can download, you can go search Wireshark on Google. You will see multiple videos on that. So what you could do is the hacker can just run Wireshark here, and even the password that this PC is sending to the switch will be received by this PC, right? So technically he has all your information for him to hack into the switch and do whatever he wants to do. So that's one of the main reasons why we wouldn't put a hub in our new technology, in the new networks as of today, right? So today almost all the big companies are replacing hubs with switch. I mean, hub was a stopgap arrangement. I think companies should not even use hubs, right? So this device sitting here, he will also get. So one of the ways to prevent that is by having another technology, another protocol known as SSH, that is secure shell. So let's see how we can enable secure shell. So that secure shell or SSH is another way of telnet. So you can do exactly things like telnet, but it is a secured way of doing telnet. That means there is a password encryption. I mean, there is an encryption of the traffic. So even today we have traffic. It's like this. Let me see, I'm just doing this on the fly. Let's say there is a secret development that's happening with the Department of Defense, right? So they have developed a beautiful technology which they want to transport to another research facility somewhere across the country. How do they do that? They do it with trucks, for instance, right? So a truck comes in to the gate of this site A, where this new technology is. There you have security guards at the gate. So the security guard would ask for the username and password, right? Like how we have. So at the moment, Telnet, it is asking for username and password. So once the password is authorized, that truck is allowed to go in. Now let's assume the truck is an open truck. That means it just has a trolley at the back, but the trolley is not covered. So they put the technology, whatever that device is, on the truck, and the truck starts moving out. Now this is how Telnet is. When the truck is moving, the load or the cargo is open, it's exposed. Anybody sitting out can just have a look at that cargo and know what it is, right? But we don't want that. We want the truck to be covered or the cargo to be covered in such a way that nobody outsiders, I mean, we want the cargo to be covered. That means the bystanders or whoever wants to look in, they should not know what is inside the truck, right? That's what SSH is. In Telnet, you have username password. That's as good as the gate, the security at the gate. They ask you for a username password. They're just verifying if you are the person who you are and if you're authorized to go in. That's authorization. You go in, you collect the device, and you come. But those, the technology or the load that you're carrying, if you don't want people to see that, you cover it, right? So SSH is like that. SSH is where the data transfer between devices is encrypted. Only those people, right, these two devices, end devices, because they know the encryption, only they can read, right? Nobody else. So even if this guy gets, when I'm doing SSH communication, when this PC1 is doing SSH communication with switch 0, since it's a hub, PC0 will get a copy of it. There's no doubt about that. But the question is, will he be able to make sense with what information he's receiving? So he might get that, he will not know what it is. Exactly like a covered cargo. People can see that it's a cargo, but they don't know anything because it's covered. They can't even see inside. So that's what SSH is. So let's look at SSH. To enable SSH, there are these 6 steps that we need to follow. So let's start. First thing is hostname, and the switch we already put a hostname, so I'm not going to do that. Hostname is done. Next is domain name. So the command for domain name is IP domain name. I can say nwking.org. You can give any domain you want. Next, we would create something called as secure key. How do we do that? We do that with a command called crypto. So we say crypto, right? We'll put question mark key, right? We're telling what, so we're doing crypto key, and we want to generate, right? So we say crypto key generate, right? Crypto is basically a command, except for SSH, you will not use crypto much now because this is Cisco CCNA RNS. But if you're doing CCNA security, people who would be following with me until the end of the series, because we will be the next series most probably that we will be starting would be our CCNA security. So if you're staying with me, then you will learn a lot more about crypto and security and very interesting stuff to come. But for now, so we say crypto key generate, right? We say RSA. Now RSA is again a encryption standard that is that's one of the most trusted in the industry. So we say crypto key generate RSA, and we hit enter. Now it will say that it is going to generate a key, and it's asking how many bits do you want in that key, right? The safest, and especially I think SSH requires some 768. Let's take 1024. That's a standard, and that's a safe key strength. So I say 1024 bits, right? So it says it's generating a key with 1024 bits. Now something I want to tell you is 1024 and 512, because 1024 is double of 512. It doesn't mean that 1024 is double more powerful or more strong a key. In fact, if you add 1 bit, so let's say if you add 1 bit, it doubles. If you remember our binary methods, 1 becomes 2, 2, 4, 8, 16, 32, 64. Every bit that we add, the number becomes double, right? So 8 bits will give you 256. 9 bits will give us 512, right? 10 bits would give us 1024. So here we are not talking about the strength. We are telling how many bits are required, right? That means 512 bits, you can do 2 to the power 512, and you can do 2 to the power 1024, and you know the difference between the strength, right? This is like infinitely large. I don't know the calculation, but if you do the calculation, you'll see how much these two keys are different, right? So don't get confused that 512 bits and 1024 bits is double security. It's multiple times more stronger than 512, right? So that's that. So we created we created the host name, we created domain name, we created a secure key. Next we'll enable SSH version 2. So we do IP SSH version 2. That's it. That's all the command is. We do that, it's going to say that okay, all IP traffic coming with SSH protocol will be using version 2. So we're telling that it's a version 2 SSH traffic that's going to come in. Next we will create users. So how do we create users? We'll say username, let's say Imran, password SSH123, right? That means I've just created a username called Imran and I put a password SSH123. Now there's one more command. So let's go back to the VTY line. VTY line is, so SSH and Telnet will both use the VTY line. So line VTY 0 to 15, these are the lines that we have access, right? So whatever changes that we make here, now it's applied to all the 15 line. We can, another way to disable Telnet or SSH onto a switch is by going and giving this command. So we can say transport, right, input none, right? So it's telling these lines, line VTY 0 to 15, allow input of none. When I say none, it literally will not let any traffic. It will not let Telnet, it will not let SSH, and it's as if those lines are disabled, right? So if I go, I'll go back to this device, and right, I'm here. I do exit. I've exit from the switch. Now if I try to Telnet, it says Telnet connection closed. I don't have another device that's connected. Why is it closing? Because I have said there's not, these lines will not have anything. It will have none. No protocols will be supported on these lines. So if I want to enable only Telnet, I will say transport input Telnet. We'll try this again now. Oops, sorry. Oh, sorry. We'll try this again. It's letting me in, right? So this is how it is. So what we'll do is we will, as a security measure, we'll not let Telnet traffic. We will only let SSH traffic. So we'll say transport input SSH. That means now if I try logging in, will it say? It say no, it will not let me access. Now we'll try to log in by SSH. Alright, so let's see how to use. So the usage, you can just type SSH and hit enter. It will tell what is the usage. The usage of this, the format for getting SSH is by doing SSH -L, username is Imran, and target is the IP address 10.1.1.10, right? It's asking for a password. What was the password we gave? SSH123 SSH123. Oops, it's not accepting that password. Telnet. Okay. All right. So okay, this is wonderful. Now this is another mistake. It's good that happened here, so that I can show. I should have added this as part of the steps required. Now what happened is I tried these passwords. It did not work. I tried SSH123, which is this. SSH123, which is what I was expecting it to accept, but it did not accept. I tried again, it did not accept. Then I tried this password, right? Which password? I went back to, if you go back to running configuration, so let me show that here. Do show run. What is the password that I have set in line VTY 0? It says password Telnet. So I tried Telnet, it worked. Why did it work? Why did it not take the username, but it chose to take the password? Now that the trick for that is in this command. Now when I say login, it literally means login using the password that is set. So, and if you are in line VTY, right, this login means use the password what is set here, right? That's what login means. Login, by default, it says it's login password. That means login using the password that is given here. But if we want it to use a password other than the one set here, we need to change that line. So we'll say login user. No, sorry, login local. Right? So when I say login local, we'll see what happens. Right? You'll see everything is changed to login local, which means use the local username and password, which is this, the username and password that is configured on the device. So it's login local. I don't know if packet tracer supports others, so if we will just do a question mark there and see what is supported. Here it only supports local, or just leave it blank, right? So we need local. But then as we learn in a later part of the series, especially security, we will see that you can make use of ACS, right? We can use TechAx, we can use Radius. These are different protocols used by the Cisco access control server. So even with the Cisco ISE, the identity security engine, which is definitely, these are things definitely not part of your routing and switching, but I'm just giving you ideas that there are devices like ISE which can use Radius and TechAx Plus. Cisco ACS is another device, so we can make sure that these devices can access the central database for username and password, right? So at the moment we will say login local, which says use local username and password, right? So let me try that again. I will exit now. I will try logging in. It says SSH123, that's the password I'm putting in, and I'm in. This, my friends, is how we enable SSH, and SSH is a practical way. So what I would suggest is all of you, as soon as you get in, you have to, I mean, if you're going to be administrators, you have to advocate with you might have to persuade, if your company is still using Telnet, you would have to talk to your manager and see if you can make all communication using SSH, and this is how you would protect your traffic, by using SSH communication, right? I hope we have discussed quite a lot today. So what you could do is you could take down notes. You could watch this video again and take down some notes. It's not much, it's very very nice, and it's very simple concepts. It's just a matter of understanding the concepts, and if you have any doubts with, let's say, logical and physical topologies, or any of the things that we discussed in today's video, please feel free to write to me at imran.rafai@nwking.org. I will answer. I get a lot of questions. Some of the questions are repetitive, so I'm very picky with the questions that I choose to answer, because some of those answers are readily available. You just have to watch the video sometimes, or maybe look at the forum messages in our, under the video you have to look at the messages. The answers would already be there, but if I think I need to answer, I do answer, but I'm trying to put in more time here. I will try to answer more questions, but try liking our page on Facebook. That will be more active. We will be discussing questions and answers there very soon. And of course, don't forget to subscribe. If you're not yet subscribed, I think you have to do it as soon as possible, because every time we add new videos, you will be immediately notified. And we have such great plans for this channel now. I'm gonna add new videos more often. I know the last video was a long time ago, but we will try to make it more faster, more active, and very soon we will complete the series. We'll start the next series, and very soon we will have a lot more activity. So don't forget to like our page Facebook, and don't forget to subscribe our YouTube channel. And thank you so much for your love and affection, and keep watching. See you soon. Bye bye.